Hello everyone, welcome to this quick video which is about IPv4 subnetting concepts. So some key things that we need to know. Firstly, basic rules for IP assignment. Addresses that are in the same subnet don't need to be separated by, they shouldn't be separated by a router, but addresses that aren't in the same subnet must be separated by a router. Very, very important. This is called the Big Five method of IP subnetting. It's what term I use, but it's something I learned from Todd Lamley, who's one of the most prolific writers for the CCNA exam. He has some great books on the CCNA exam, and he's been writing for many years. But what I learned from his book, so 5-step process for working out the answer to subnetting problems. You'll see in my practice test video on subnetting that I use this to work out the answer to the final question. So firstly, we just want to be thinking about how many subnets are being created. So X is how many bits are on. How many bits are on in the subnet mask. If you were to write this subnet mask out in binary, how many bits are on? 2 to the power of x is how many subnets are being created. Okay, so you do 2 to the power of how many bits are in the subnet mask. For example, if you got a subnet mask of 255.255.224, but .224 in the final octet is 3 bits are 1 and 5 bits are 0. So you do, what we're doing there, 2 to the power of 3, because to make 224, 3 bits on, so we do 2 to the power 3, which is 2 times 2 times 2, which is 8. Okay, 2 times 2 is 4, times 2 is 8. So 2 to the power of 3 is 8. That's what we're doing there. How many hosts are being, number 2 is how many hosts are being created per subnet. So how do we work that out? 2 to the power of how many unmasked bits are. So with 255.255.1.224, you've got 5 bits that are 0. You do 2 to the power of 5, which is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32. But we're not finished there. We need to take 2 away, because one IP address is reserved for the subnet ID, or they're reserved for the broadcast ID, broadcast address, sorry. So 32 minus 2 is 30. 30 is how many hosts are being created for that subnet mask. Okay, a slash 27 subnet mask that would be 255.255.224. What is the increment size? Well, that's 256 minus the subnet mask value. In this case, it's 224. Okay, that is because the subnet mask is 255.255.224 in dot decimal notation, DDN. So 256 minus 224 gives us the increment size, the magic number. So what is that? 256 minus 224 is 32. Is 32, right? So that is the magic number. That is what our subnets will go up in. They will all go up in 32. Okay, from one subnet ID to the next ID, you'll see an increase in 32. Then what's the broadcast address for your subnet? That's the last IP address in each subnet range, and then the valid hosts are the first and the last IP address. Sorry, after the subnet ID, and all the way up to the last IP address before the broadcast ID, the broadcast address. So the following subnet, the following IP address after the subnet ID, and the last IP address before the broadcast those are your valid hosts there. So that's why I use the Big Five method for subnetting. Classful IP addresses versus classless IP addressing. You'll see these terms thrown around. Classful addressing is a concept which refers to an IPv4 address in 3 parts: network, subnet, and host. And classless addressing is a concept that ignores the class A, B, and C rules. Instead of 3 parts, there are 2 parts: the prefix part and the host part. Just beware that the terms classful and classless are used in at least 3 different contexts in networking, so IP addressing, routing, and routing protocols. Now, determining the number of subnets, when designing a subnet, we need to think that the engineer will need to think about the internet as being documented and count the locations that require subnets. So one subnet should be planned for the VLAN, one for the point-to-point serial link, and one for the Ethernet WAN, link. Okay, the Ethernet line service. So subnet should be planned for each. If you got for each VLAN that you have, each point-to-point serial link you have, and each Ethernet WAN link that you have, Ethernet line service. Now let's look at the private IP address ranges, okay, defined in RFC 1918. So class A, okay, this is what used in private IP addressings, okay, in organizations internally. 10.0.0.0, okay? That just gives you one network. 172.16.0.0 to 172.31.0.0, that gives you 16 subnets there. 16 subnets, 16 networks, sorry. That gives you 16 networks. 192.168.0.0 all the way to 192.168.255.0 gives you 256 networks. So you can see there's from 1 to 16 to 256. They're all private, but B gives you more than A and C gives you more than B. So very important to be familiar with these three ranges. Now, if we were to look at the public IP addressing, when it comes to public IP addressing, there's 5 ranges. You've got class A, B, C, D, and E. A is 1 to 126, and that's is for unicast purposes, large networks. Then B, 128 to 191 is for unicast, medium-sized networks. C, 192.2 to 223 is for, it's also unicast, but for small networks. So we're going from large networks with class A to class B being medium-sized networks, class C being small-sized networks. You can see that these ranges also decrease in their sizes as well. And then D is reserved for multicast addressing. E, okay, so D, sorry, 224 to 239, and then E, 240 to 255. That's reserved, and it was used for some time for experimental purposes. Then, just going back to the RFC 1918 private addressing. Expanding on here. Don't be confused. This is expanding on here. More details, but you can see 1 to 126. Okay, so the biggest range out of these three. These, remember, are used for unicast addressing. Okay, large networks, medium-sized networks, small networks. Okay, so we've got a total of here 126 networks, 16,384 networks, and then about over 2 million networks with the class C here. Now, hosts 2 to the power of 24 minus 2, 2 to the power of 16 minus 2, 2 to the power of 8 minus 2. Then, octet bits in the network portion. 1 octet, 3 octets. 2 octets with class B. Class C, 3 octets for the network portion, 1 octet for the host portion. That's the default mask there for class A, default mask for class B, default mask for class C. So 1 octet is 255 here. That's the network. Okay, that indicates the network portion. Here's 2 octets of 255. That indicates 2 octets for the network portion, and 3 octets here are 255. 3 octets for the network portion. So that brings me to the end of this video. Thank you so much, guys, for watching. Really appreciate it as always. Please like, share, and subscribe if this video was beneficial for you, and I'll see you in the next video. Thank you.